Good morning, class. We are looking at application of trigonometric functions. Section 5.4, right triangle trigonometry. So section 5.4, right triangle trigonometry application. We are going to solve right triangles and solve applications. Those are the objectives. So again, refreshing your memory about fundamental identities, the unit circle. Trigonometric functions are periodic with the period of 2 pi, with the exception of tan and cotangent. They are all odd functions with the exception of cosine, which makes it also secant. Other fundamental identities include Pythagorean identities, quotient identities, reciprocal identities. And then we added sum and difference formulas, such as sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Double angle and half angle formulas, we created them by using the sum and difference formulas. For example, sine of 2 alpha is 2 sine alpha cosine alpha. Now, cosine to alpha is interesting. It takes various forms: cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. Tangent is basic, it's sine over cosine. So what happens is, then we get the half angles, okay? Starting with sine squared from here, if you look at this formula, we can create sine squared alpha is 1 minus cosine to alpha over 2, and then sine squared of alpha over 2, and then these are the results. The same thing happens for cosine. The green one results in cosine here. And here's the tangent. Tangent, as always, sine over cosine. And we do have other formulas, product to sum and sum to product formula. Now, solving right triangles. When we look at ABC, triangle ABC, adjacent to A, opposite to B, adjacent to B, opposite to A, and here's the C. We use capital C for the vertex and lowercase c for the sides opposite that. Pythagorean theorem, a squared plus b squared is c squared. If this is 90 degrees and the total interior angles must be 180, A and B must add up to 90 degrees. Complementary angles, also known as complementary angles. So if we call this angle theta, then sine theta is the opposite over hypotenuse. Okay, so it makes it B over C. Cosine theta is the adjacent A over the hypotenuse C. Tan theta is the opposite B over the adjacent A, and the rest of them are the reciprocal of those. For example, cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over the opposite. So as long as we have those three, the reciprocals are the answers for those. So it's very straightforward, everybody. Find the value of each of the 6 trigonometric functions. Well, this is theta. Opposite theta is this side. Adjacent to it is this side. The longest side opposite the 90-degree angle is called the hypotenuse. So all we have to do, calculate this. As you know, Pythagorean theorem says a squared plus b squared equals c squared. So 3 squared plus this side squared equals the 5 squared. So we call that b. And obviously, this is 9, this is 25, b squared is 16, and b is 4. Okay, b is simply 4. So, for example, if I'm interested in sine of theta is the opposite, 4 over 5. I want cosine of theta is the adjacent, 3 over 5. I want tan of theta is the opposite, 4 over the adjacent 3. So I have those, and the rest of them are the reciprocals. So 4 over 5, 3 over 5. As long as you have even those two, you can go with the identity. So if you divide this one by this one, you get 4/3, and the rest of them are the reciprocals. For example, cosecant, you go to sine and flip it over, 5 over 4. Secant, you go to cosine and flip it over, 5/3. Cotangent, you look at tangent, the reciprocal of that is the answer.
I have a question.
Go ahead.
So basically, to find cosecant, secant, and cotangent, we just flip whatever we got for a sine, cosine, and tangent.
Exactly, because what is the formula for cosecant? 1 over sine. What about secant? 1 over cosine. What about cotangent? 1 over tangent. Those are called the reciprocal identities. So that would be the fastest way to come up with the answer. We want to solve, anytime we want to solve any triangle, that means find all the angles, all the sides. So we want to solve a right triangle where A and B is given, and we want to find the rest of them. When A and B are given also this angle, we know it to be 90 degrees. So using Pythagorean identity, we can find the C. A squared plus B squared equals C squared, which means 3 squared plus 2 squared is C squared, right? Those are the given. So this is 9 plus 4. And so C squared is 9 plus 4 over 13. C is square root of that. Now, we have all sides. To find all angles, we already have one of them, 90 degrees. So as long as we get one of those, we can find the last one. So for example, since these two values are given, we are going to use the given values. The reason I don't want to use the one we calculated in case we made a mistake in the process of calculation, try to use what is given. So as you can see, tan of A is the opposite, which is 3, over the adjacent, which is 2. And that means tan inverse of 3 halves must be A. Tan inverse of 3 halves must be A. And you use a calculator to come up with the answer. So tan inverse of 3 halves And what you do, of course, it depends on how many decimals they ask you. In this case, if you want to go with one decimal, 56.3 degrees. If you want to go with two, would be 56.31 because of this number nine, this changes to one. So it depends. So if we have A, B would be 90 minus that because A and B must add up. Those are to 90 degrees. Those are complementary angles. So 90 minus 56.3 results in 33.7. We are done. So everything that we found, it's really not a bad idea to put them in one place so it becomes organized. A, B, C, lowercase a, B, C. Lowercase a, B, C represent the sides, okay? And the opposite sides, remember that, okay? We're going to continue with this question where one side is given as a 2, one angle is given as 40 degrees, and we want to find the rest of it. So first and foremost, we know this is 90 degrees and these two must add up to 90 degrees. So if you subtract this number 40 degrees from 90, it gives you the value of B, which is 50 degrees. So we have all the angles. 40, 50, of course, this is 90. Now we want to find all the sides. This one is given. So if you look at tan of, for example, 40 or 50, you can find the A. So tan of 40 would be A, the opposite, divided by 2. Cross product makes A 2 times tan 40. Because divided as such. Now, of course, you use a calculator for tan of 40. You multiply it by 2 and you get almost 1.68. Now that this is 1.68, we have a number of choices. We can use Pythagorean theorem, a squared plus b squared equals c squared. We can continue with what we did here and say, for example, cosine of 40 is a 2 over c. Why am I using cosine? I can use sine of 40 as 1.68 over c. I'd rather use what is given to me, again, because in any intermediate step, if we make a mistake, we don't want to take that route. So we want to use what is given as much as possible. So we're going to use 40 degrees and we're going to do 2. So cosine of 40 is 2 over c. And therefore, one of the things that I want to make sure you know, when you have two fractions, you can interchange c and cosine 40. You can say c is 2 over cosine 40 because it comes from this cross product. You can say c is 2 cosine 40, and then c becomes 2 over cosine 40. But learn this, if you have two fractions, you can interchange, for example, these two or these two. And so, again, using a calculator results in 2.61. Normally, If it's not mentioned, when you do the rounding, you do with 1 or 2. Normally, they use 1, but in case. So it's 2.61. All right. Complementary angles, as it was mentioned before, the sum is 90 degrees. Co-functions of complementary angles are equal. In other words, the following. Sine of 30 is the same as cosine of 60. Notice these two numbers, they add up to 90. So sine and cosine are considered co-functions. Tan of 40 is the same as cotangent of 40. And all you have to look at the concept of a tan, which is opposite over the adjacent versus cotangent, which is the adjacent over the opposite. So for the 40 versus 50, that's how it works. And therefore, tan and cotangent are considered co-functions. The same thing for secant. Secant of 80 is cosecant of 10. And secant and cosecant are considered co-functions. Remember, the two numbers, 30 plus 60, 40 plus 50, 80 plus 10, they must add up to 90 degrees. So with that being the case, sine of 62 degrees, if we go with that, all you have to do say is cosine of 90 minus 62. 90 minus 62, so cosine of 28. Tan of pi over 12. You're going to use cotangent of pi over 2 minus pi over 12. Remember, 90 degrees is the same as pi over 2. Pi over 2 is 6 pi over 12 minus pi over 12 makes it 5 pi over 12. So cotangent of 5 pi over 12. Cosine of pi over 4 is the same as sine of pi over 4 because pi over 4 plus pi over 4 is 90 degrees. Or you might say this is how you get this, okay? Cosecant of pi over 6, so pi over 2 minus pi over 6, which is pi over 3, makes it secant of pi over 3. Could somebody read this question for us, please?
A surveyor wishes to find the width of the river. He set up his transit, an instrument that measures angle at C on one side and sighted across to point A on the opposite side. After turning through an angle of 90 degrees, he walks 200 meters from C to a point B, and finally, setting his transit at B, he measures angle ABC as 20 degrees. What is the width of the river?
Excellent. Go over here. The distance of 200 meters, turning it around. So this is exactly 90 degrees. We are interested in finding the distance of AC or B, which is the width of the river. So we do the measurement here. We go to the right. This is 200 meters, doesn't have to be 200 meters, okay? So after we set this up here, then we move it however many feet or meters that we want, in this case 200 meters, and we recalculate. So clearly, tan of theta is the opposite B or AC, or the width of the river over the adjacent A And so B is what's missing, what we are interested in. And A is 200 meters. So you have measured this distance because you can measure it on your own side. You have measured this angle. And so B is the product of 200 and tan of 20. Again, cross product. And you get 72.79 meters. 72.79 meters. All right, let's look at some definition. Angle of elevation and depression. Angle of elevation is the angle formed by the line of sight and the horizontal plane for an object above the horizontal. So here's the horizontal line, and we're looking at something above the horizontal line. This is called the line of sight, and this is the angle of elevation. Angle of depression is the angle formed by the line of sight and the horizontal plane for an object below the horizontal. So we are standing, we are looking down. Here's the horizontal line. Here's the line of sight. Here's the angle of the depression. You can also look at this concept. Angle of elevation versus angle of depression. Or if you are looking at a subject below the horizontal line, angle of depression, above that, angle of elevation. Could somebody read this question, please?
Meteorologists find the height of a cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. A ceilometer was set up such that its light projector is 300 feet from its projector. If the angle of elevation of the light detector is 75 degrees, find the height of the cloud.
Excellent. So here's the setup. The light detector. Here's the base B. Here's the cloud height or the vertical light beam. This is where it's got illuminated. This distance is 300 feet. 300 feet from the projector. Theta is the angle of elevation, 75 degrees. So we do this drawing. This is 300 feet. This is 75 degrees. This is the height. And obviously tan of theta, tan of 75 degrees. Tan of theta is H over B. H over B, that's the best course of action. So tan of 75 degrees is H over 300, which makes the product of the two as H, the product of these two equals H, 300 times tan of 75 degrees. You use a calculator, of course, at this point. You calculate this, you multiply it by 300, and it gives you the answer you're looking for, which is 1,119.62 feet. Could somebody read this question, please?
A statue of Ceres, the Roman goddess of wheat, can be observed at the top of the Board of Trade building in Chicago. Observations 400 feet from the center of the building reveals that elevations to the base and to the top of this statue are 55.1 degrees and is 56.5 degrees respectively. What is the height of the statue?
Excellent. So this is the angle that it makes to the top of the building, and this is the angle that makes the top of the statue. It's a little bit more, as you can see. So if we were to draw a vertical line here, okay, what happens? We have these two cases, everybody, where this one, for the 55.1 degrees, B is the height of the building, and this one, just a tad more than B, would be the distance from the bottom to the top of the statue. So, and the distance from here to here has been calculated as 400 feet. So we can use tan of 55.1 degrees as B over 400, calculate the B, tan of 56.5 degrees as B prime over 400. And what are we looking for? We are looking for B prime minus B. What is the height of the statue? What is the height of this piece at top? B prime minus B. So tan of 55.1 degrees, according to this, is B over 400. The cross product gives us the B. 400 times tan of 55.1 degrees. We get 573.39 feet, again, using a calculator. So we are using this one, okay? And we are calculating this height B. Now we're going to go to the next one. This time, tan of 56.5 degrees is B prime over 400. And the cross product gives us the B prime as the product of 400 and tan of 56.5 degrees. Using a calculator results in 604.33 feet. So the difference between these two numbers, B prime minus B, that means 604.33 minus 573.39. The difference between the two, which is 30.94 feet, is the height of the statue. So the height of the statue, B prime minus B, is 30.94, almost 31 feet.